Windows, doors, very important part. One of the 5 principles of passive house. The selection of window is very important to the final outcome of the building to which you're going to be doing, not just because of the air tightness, but also the potential of cold bridge or thermal bridge that can be created by your windows. So windows are an important part and needs to be looked into and researched for what's right for your development, for your project. This is especially important in retrofit, because a retrofit, if you're replacing doors and windows, you can't design the aperture to go around it, the structural envelope to go around it. It's only what's there. So select the right ones and just take a little bit of time and make sure you get the right ones for your project. It's a window. What else do I need to know? Well, this is what this is going to, hopefully we're going to explain a little bit as we go through. What do we need to know about a window? It's not just something that let light in. It's not just something that's nice to have in your wall. It does a function. It actually does a lot within the build, especially in a passive house. U values. U values are something we talk about all the time. In fact, in the different videos, we go through about the different values of that particular item or subject to which we're covering. No different with windows. There's lots of values to take into consideration. The first one being the U value. Now, the U value over the years has increased efficiency so much over the years. Okay, a typical single glaze unit would be 5 watts per meter square. Now, what does that actually mean? The U value is the amount of energy or the amount of heat you're losing. So if you've got a large amount of heat going out, then your U value is going to be really poor. But if you've got a really small amount of energy and heat going through, it's better. Now, with a U value, the lower the U value, the better. Okay, so if you've got a U value of 5, it's really poor, because the value is how much you're losing, not how much is being retained. Unlike an R value, which tells you what's being retained, it actually tells you what you're losing. So you'll be losing that cubic meters, that square meterage of volume of heat through that object. So when it comes to passive windows, the thermal transmitters of the window needs to be vastly improved, other than what's considered as a standard single glaze or even double glaze unit. So as we can see, U value, watts per square meter per degree of Kelvin. That's what this means. So save complication is just a U value of, and that way everybody understands it's the most commonly used value that we use. Do's and don'ts of windows. It's quite important. Right. Do minimize transoms and mullions in glass. Check window sizes to achieve what are achievable by your manufacturers, because some manufacturers don't always produce the size window you may need. Use PHPP to assess components, and so PHPP, the Passive House Pattern Package, this is going to be a completely different lesson, but you need to know that what you need to achieve will be given to you in your PHPP, and your windows and doors are no exception to that. Certificates. When you look at a window, they might turn around and say, this is an excellent product, this does that, this does this. Fact of the matter is, they don't all do it. If you're going for passive standard windows, get one with the correct certification on it. Don't assume a frame is going to be a particular value. If you've got one frame that looks very close to another, the U values could be very different, even though they look the same, because it's been constructed and designed in a different way. PHI component certificate or manufacturer's third party test certificate or performance. That's all to do with those values. Forget to adjust the performance of any roof lights within the PHP calculation. Okay, so do's and don'ts. We're going to explain this more as we go through. It's a window from the box. When you get your window delivered, this is what it should look like. There are variances. There's many different makes out there. This particular one is an aluminium powder coated fronted timber frame window. The casement itself is timber. It's triple glazed. So this is what it looks like. But notice there's no way of there's no obvious way of fixing this window. The reason is most passive house windows are fixed with a bracket fixed to the outside of the window and then to the structural opening, not through the window itself. Once fitted, the window you just saw has now been fitted. What we've done is we've airtighted around it with a membrane and an adhesive tape, which is the correct tape for that particular membrane, and we've lapped onto the window. The reason we've done that is air tightness is key. Air tightness around windows is most important, and doors. Okay, if you're going to get a leak, 90% of the time it's going to be around your doors and windows. So once it's installed, well taped, insulated around, a window that's fitted correctly will always have some form of insulation around it. Also, the brackets, make sure the brackets are covered, because most of the time there will be brackets within the side of the reveal. This is just a nice example of a development that Pure House are involved with. This is going to be a Pure House development. And the windows. Now, the windows on these sides are particularly quite small. The reason is the size of window actually governs or helps or hinders a build. So the design in the PHPP will tell you what windows size should be on what side of the house, depending on the orientation. So you'll get some sizes on some sides of the house which are quite small, and on the other side they'll be a little bit larger to make maximum use of solar gain. And shading. You'll also notice that certain areas have got a shaded or a box around the window and other areas haven't. It's all been calculated and designed in the window. Are you confused yet? Ha ha! Yes, is the answer. Most people are. Don't get confused. It's very basic. All you really need to know is what the final value of your window is. And you've done the calculations from your PHPP and you've got your design. What this is an outline or a configuration which would be given in your PHPP or a design. And all it is given similar information to different areas around the window. So you've got the area of glazing, the project edge of seal. That is your bars or the seals around your glass unit. The project area of the entire fenestration, what that is the makeup or design and the structure. Don't be confused with that. It's just the design of the structure of the window. Edge of glass U value, frame U value, overall U value. This is what you want to look at. Your U value wants to be your overall U value. That's what you look at when you decide what windows you need. This is just the calculations or the way that a PHP person or that sort of thing or a designer would look at it. All you really need to know is what the final value of that window is. Glazing. What types of glass are there? As in most passive windows, we use triple glazing. The reason is the values of that glass give us. Now, single pane glass is U value of 5.8. That means that you've got 5.8 volumes of Kelvin going through that glass, which is a lot of energy lost. Now, we've only got to open it up, put a spacer bar in between, and we're already down to 1.9. Open it up a bit further, 28mm unit with a argon gas or a gas in between, an inert gas, down to 1.2. Now, this is why we use triple glazing. Triple glazing is you have glass which is coated. So you have a treated coated glass and standard glass. So what we end up with is 0.8. That's your U value of the triple glaze unit. So if you can see from your original 5.8 to 0.8, you've saved 5. That's massive amount. Bearing in mind that every time you add a piece of glass, it costs more money. Also adds weight. But triple glazing with the correct coated glass is the way to go, unless you're going to use vacuum units. Now, a vacuum unit in itself is less than 7 mil in thickness. It's got a vacuum in between, so nothing can go through it. It's very difficult for heat and energy to go through that. So that actually gives you a U value of 0.7. So potentially a vacuum unit could be used for a development, but typically triple glazing is used because 0.8 is about what we're looking for. When we say 0.8, they're normally a little bit lower than that. But triple glazing with the correct coating is the way to go. But if you want thinner frames, especially to a retrofit where you've got to make it look like the original frame or the original depth of frame, then potentially a vacuum unit could be for you. So research what glass you need, but if you go for passive house certification or passive house standards, even if you're not going for certification, you just want to reach maximum standards, then triple glazed or vacuum. Let's make it simple. Establish standards. When it comes to standards of windows, it gets very confusing. The whole world of windows and doors can get confusing very quickly. The basic things is just understand what value you need by what glass and thickness that you're using, and also the standard. Both these standards are up to passive standard. Okay, passive house certified, but up to passive house standard, but not certified. It's the only difference. They do the same job. Performance. What performance? We like this. According to the UK building regulation, these windows are the same. Okay, so we have a frame with nothing, just top opening, and we have a frame with lots of transoms and mullions. We have a small opening frame, light, and we have a large opening casement. Okay, according to building regulations, it's not actually the case. Okay, why did that not go? Right, let's look at the U values. The U values are what we're looking at. It's what we're interested in. Now, building regs say these windows are the same. No different. Well, actually, they're very different. The reason is if you look at the values of this, which is a passive certified or passive standard window, it's 0.85. That's your U value. We've gone through the U values. That's how much energy is going to be lost through that window. Here, we've got lots of transoms and we've got mullions. We've got a U value of 1.25. So the U value figure is higher, which means this less efficient. You're transferring a greater amount of energy through it, even though regulations say it's the same. It's not the case. So this is 47% worse than that window. You got one window in a house, that is almost negligible, believe it or not. But you've got 10 windows, it's 10 times that. So always look at your U values and your actual design. Okay. Traditionally, windows are badly installed. Basically, we get a window, we put it in, put through a few screws through, and then we plaster up to it. With a passive house standard, we don't do that. What we do is we fit the window, we make sure it's well connected, well fixed with the correct brackets or really good quality brackets, and it's airtighted and sealed to make sure that it does its job. Right, fully installed doors and windows. The thermal image here shows of what you're going to get potentially. This is actually a retrofit job. It's not been done. This is an existing building which is potentially going to be retrofitted. But this is a fairly new door in an extension. So therefore it gives a good idea of what we're dealing with on a traditional build. So this is the picture. And the same picture thermally imaged. You can see it's the same picture, but you can see the cold spots at every junction. So the seal is not great because you can see the cold coming through the seal. The seal at the bottom, you can see it coming through. And the connection point on the floor line. If this was a passive house or going to passive standards, there would be an insulation underneath the door. And there'd be an insulator around the window or around the door, which would help to cancel out this area. This is why fitting the windows correctly is so important. You can see the results of a poorly fitted door or window. But this is how most doors and windows are fitted these days, to this standard. And this is the result. This is why we need to change the way we think about our doors and windows and why it's so important. Another thermal image. Outside -5, inside 20 degrees. Okay, typical passive window from inside. Okay, you can see the heat. You can see it reflecting and holding on. Even the glass is still orange. So that means it's resisting losing too much energy. So the U value will be really good because you're not losing a huge amount of energy through the glass. But down here, this is typical double glaze window from inside. So passive standards, typical standard. So you can see the difference how even though the glass is trying to resist the loss of energy, the rest of it, the window itself and the wall around it and the connection points actually really cold. So we're losing a lot of energy. This is why thermal imaging is so important and testing is so important because we need to show the evidence of what it is we do. As we do more retrofits, as we do more passive houses and do more construction up to passive standards and following the principles, we learn. We learn on every project and we're advancing and improving in what it is we do. And this is why we need to learn and why we need to improve what it is we do. Styles compared to, right, styles compared, all 1230 by 1480 size windows. Okay, and then we can consider glass areas, solar gain, and of course cost. Cost is most important. So where is the best value? So what we've got here is we've got 4 individual designs. We've got just the frame. We've got a frame with a casement. We've got a frame with an opening light and a casement. And we've got a frame with mullions and transoms in, lots of them, and glazing barns. So therefore, we have the same size window at 1230 by 1480. Same size window, different designs. So what does that mean? this one, which is just the frame and a piece of glass. That will be a triple glazed unit. D is 0.79, which is very good. And the glass is 76% of the total area. So what we've done now is we've gone from frame with an opening light, with just the basic frame with our triple glaze unit in between. So we've gone to U value of 0.85, still very good. Glass, 69% of that area is 69% of glass, and it's still 0.85 of U value. Then we come to this one, we have an open light, and so we've got a transom through the middle, mullion through the middle. So we've got a U value of 1.6. Simply by adding this, we've gone from 0.85 to 1.16. And that is also glass coverage of 61%. So we've limited the amount of light, but we've increased the amount of energy that we're losing. Every time we lose light, we're going to lose energy, because light actually helps to heat our houses. So we've gone now to 1.25, and we've only got 56% of area of glass. So what we've done is we've gone from a really efficient value to a very good value to which would be considered these days as pretty poor. But this is the windows that most people are fitting, and to this standard. And they're losing light, and they're costing more money, and they're losing heat value because of the design. This window, typically, even with triple glaze unit, £293. 532. The reason that leaps up is because you've got a lot more work in the unit itself, because you've got an opening light, still with a triple glaze. Then we've gone to 725. Now, typically this style would only be double glazed. So you're already losing thermal efficiency through the glass, as well as losing it through the frame. So we're going up in price. Then we come to this window. This window's the same size, is losing a lot more energy, is letting in a lot less light, but it's costing you a huge amount of money in comparison to the others. So we're going up in price, we're going down in U value, and we're going down in light, which is coming into the build. So your design of the frame and the windows is actually really quite important.